Hello everybody. In this video, we'll present the major enhancements of STRAP 2022. One of the major improvements is the ability to define a surface of shell elements as a wall. This will allow to view wall results and design the wall in the reinforced concrete module. Usually this option will be used for irregular shapes of walls and adds flexibility to the user in addition to the regular wall element that is already available in past versions of STRAP. We can see some examples of irregular walls that the new feature will be useful for. To the right, we see a wall that its section varies along the height axis. In the middle, there is a wall with a circular opening, and on the left, a skew wall. Let's see an example. On the right side of the screen, we can see a surface of shell elements, and the width varies along the height axis. Under walls, a new option for element wall is available. This option will allow us to define a wall based on a surface of predefined shell elements. Once we click Elements Wall, we must define the wall's contour. The selection of the first two nodes will define the wall's baseline, and two more nodes to enclose the wall contour. At the end of the definition, we can see that the wall is filled with a gray surface, and we can see the wall number, W1. For this example, we'll define another wall on the top of W1 to cover the entire shell element's surface. On the left side, we can see a shell element surface with a rectangular opening and another irregular opening. We'll define this surface as a wall as well. The definition of elements as walls doesn't affect the stiffness of our model. This will only affect the results display and will give us the option to design these surfaces as walls in the reinforced concrete design module. In the loads module, we'll define 10 tons of joint load in the X1 direction at the top level of the walls. Loads can be applied perpendicular to the wall or in plane at any desirable point. In the Results module, under Wall Results, we can see the option for the result type, moments, shear force, axial force, etc. Let's see the moments in the wall's plane, moment in the X direction. We can see on the left 40 ton-meters, which is the 10 tons horizontal load multiplied by 4 meters, which is the wall height measurement. The same can be seen on the wall on the right. Let's see the shear force in the X direction. We can see the 10 tons that was defined at the wall's top level. We'll move on to the concrete module for wall design. Under walls, clicking Compute will calculate the walls, as we can see in the wall results summary table. Detailed results can be displayed as well. At the top, we can see a side view of the wall and its thickness. Below that, we can see the calculated reinforcement. In cases where the wall section varies in length, the shortest section is taken under account for design. In this example for W1, the shortest section length is at the base of the wall and equals to 2 meters. For the design loads, the program applies the design loads from the wall top level, bottom level, and at the wall middle. For the example on the left, the program will assume that the wall section is the section between the openings. In the detailed results, this can be seen clearly. If the user wishes to get a more conservative design, The wall can be splitted to several walls instead of one wall unit. Let's go back to the geometry module and split W3. Under Walls, click Revise. Revise allows us to revise the wall contour or to split the wall. Split is available along the height axis or the baseline. We'll select Split Wall, select W3, and now we can select nodes along the baseline or the height line. We'll split at the opening start and end points. Under Output Display Data, Walls List, we can see information about the defined walls. For example, W1 is defined with node numbers 1, 2, 3, and 4. Its area is 10 square meters, the height is 4 meters, and the volume 2 cubic meters. Another major improvement is related to STEELDESIGN. A detailed calculation report is available for the design according to the European standard EC3, the American standard AISC, the Brazilian standard NBR 8800, and the Israeli IS 1225 for hot-rolled or welded steel. Also available is the European EC3 in the American AISI for cold-form steel. Let's see an example for the detailed results for hot-rolled section based on the European EC3. When asking for detailed results, checking Show Step-by-Step Calculations will reveal the detailed calculation. Under the Detailed Results table, we can see the addition of detailed calculations, formula numbers, and parameters for each code check. Let's move on to the improvements in the geometry module. Under Display, an option to display the model's center of gravity on the screen is added. Clicking this option will display the origin of the model's center of gravity. To display the center of gravity coordinates value, right-click on a blank spot on the screen, then Model Properties, and we can see the center of gravity coordinates value. In the Properties table, there is an option to revise the section direction and material via a drop-down menu. For example, we can see the orientation of property number 1. Revising the direction from major to minor, and now we can see that all the beams with property number 1 are revised. Another new feature is the ability to zoom on nodes or elements that were notified during a geometry check or errors during the solution. Let's see an example. Clicking Check Geometry, we can see that the program found that beam number 21 have been assigned with an undefined property. In the option Zoom, Move Window Center, there's an option for Zoom on Error. We can see a table with errors after geometry check, for example error number 2, and errors of singularity, error number 1, that was obtained during a prior solution. We'll select line 2, click Zoom, and we can see beam number 21 with property number 5 assigned to it. Going into the beam's properties table, we can see that property 5 is undefined. We'll define property 5 and go back to Move Window Center, Zoom on Error. Since we know this error is now resolved, we can hide it. In case we want to see the hidden lines, we can check Show Hidden Lines. Errors during geometry check will be refreshed and will be deleted from this table after being resolved. Errors received during the solution will only be deleted after another solution and assuming that the problem is resolved. Let's zoom on error number 1, singularity. We can see the reason for this error is that the degree of freedom x4, which is rotation around the x1 axis, is unrestrained. To resolve this, we'll define a restraint for rotation around the x1 axis. We'll solve the model and go back to the geometry and ask to zoom on error. We can see that no errors were found. Let's move on to the loads module. When defining a new load, the load can be assigned to a group. Under Assign to Group, all predefined groups are available. This option will allow us to create load case combinations automatically based on the predefined combinations in the library of combinations or by a selected code. In this example, we can see 8 load cases that are assigned to groups. During combination definition, the button By Code is added. We can see all 3 load groups in the combination table. Clicking By Code will allow us to select the design code, and all combinations and factors of the selected code will be assigned to the load groups automatically. For this example, we'll select the Israeli steel design code IS1225. We can see that 5 load combinations are created with the load factors for each load group. Now we'll display all the combinations that were created based on the code and the load group's type. While defining combinations, another option is by library. The difference between by code or library is that by code the program creates all combinations, while in the library the user may select only a part of the required combinations. Clicking library will show all the available combinations of a selected code. By using the Control key, we'll select 3 combinations from the list, and we can see that all 3 were added to the combinations table. This option is also available when defining combinations in the Results module. Let's see another example for a concrete structure. In this example, we have 4 load cases that are assigned to 2 groups, Dead and Live. We'll define the combinations in the Results module. Go to Combinations, then Define Revise. We'll select the By Code option, and then select the Israeli code for concrete design IS466. We can see 3 combinations created automatically. 2 load cases are assigned to the Live group. As a default, for load cases in the live group, the program assumes that the live load don't act together and creates, in this case, two combinations, one for each load in the group. If we look into the combinations list, we can see 6 combinations, and loads 3 and 4 that are assigned to the live group are alternate. This definition is related to the group type and can be revised under Combinations, Group, Add Revise. Select the live group. We can see the load cases that are assigned to it. Under Combination Generation method, instead of a different combination for each load in the group, we'll select one combination that includes all loads in the group. Now when we display the combinations list, we can see only 3 combinations, and the loads in the live group are summed together. For global load definition, under Load Type, rectangular area is added. This option allows to define an area load by selecting 2 nodes or 2 coordinates. Let's move on to the Results module. When displaying axial force for beam elements, compression is colored red and tension is colored in black, and the program displays the signs for compression and tension. For displacement results, the max displacement is written at the bottom left of the screen. For reinforced concrete slab deflection calculation, the following options are added. Under minimum reinforcement, the user can now specify a minimum reinforcement, diameter, and spacing. When selecting minimum for slab or slabs walls and specifying the diameter and spacing, STRAP will calculate the required minimum reinforcement. For the slab deflection calculation, it will consider the maximum between the calculated and the specified. Under User-Defined Reinforcement, Defined Element Reinforcement button is added. This button allows to specify top and bottom reinforcement in both directions. After the definition, the user will be asked to assign the definition to selected elements. Another new option is to deactivate certain combinations for reinforcement calculations. Let's move on to the STEELDESIGN module. For combined beams, the program displays error at the beginning, at the end of the combined beam. Under Draw, Support Display Parameter option is added. This option allows control for the display of supports and combined beams. For example, we'll uncheck the combined beams, and the symbol doesn't appear on the screen. This option applies for supports as well. For example, buckling around the minor axis. In STEELDESIGN Setup, a new button, User Steel Type, is added. This option allows the user to define user-defined steel types. Let's see an example. Click Add Type, we'll give it a name, insert the yield strength and the ultimate strength. The yield strength can be reduced based on the thickness. For example, for steel thickness larger than 12 millimeters, the yield strength would be 340 megapascal instead of 350 megapascal, and so on. The defined steel types will be available for the current model and are saved for the next models in the future. Under Defaults Steel Grade, we can see the user-defined steel type added. Thank you very much for watching.